this is the Thevenin's equivalent circuit of an voltage amplifier. And you know, in the input side, you have two resistors, Ri and Rs. And they have given this condition, Ri should be very much larger than Rs. Can anybody say why is this condition given? Why is this condition given? Ri is very much greater than Rs. Why should the input resistance be very, very large compared to your source resistance? What is the reason for having this condition, Ri very much larger than Rs? What is the reason? I have told this reason many times. What is the reason?
Very little load is applied on it.
Load, I am not talking about load, I am talking about the input side. You see, input side, you have two resistance, Rs and Ri. Why they are saying Ri should be very, very large compared to Rs? What is the need for Rs being very large compared to your Rs? What is the reason? I have told this reason many times in the class. I don't know if anybody is listening or not to the class. See, whenever you are having an amplifier, the amplifier should always draw very less current from your source, or the amplifier should not disturb your source. So when is that possible? When an amplifier can draw less current when the impedance is high. For the input side, what impedance is there? Input impedance. So Ri should be very much greater than Rs, so that your source is safely working. The source will not be drained. And output side, you see R0 is very much less than RL. Only when the output resistance is very less, the transistor can transfer the entire amount of useful power to the load. If R0 is very large, that power is getting blocked here itself, so it will not reach your load. Ideally, R0 should be 0, Ra should be infinity. So if R0 is 0, whatever current coming out of the amplifier will be available in the load. But practically, you will have some value of R0. And that value of R0 should be very, very less. So these are the basic constraints you will be having for any amplifier. The input impedance of the amplifier should be very large. The output impedance of the amplifier should be very, very small. The input impedance should be very large because it should draw less current from the source, or it should not burden the source. Why the output resistance or impedance is very, very less? So that it can transfer the effective power outside from the output of amplifier to the load in a efficient way. That is the reason why these two conditions are put. So if the external load resistance RL is very, very large compared to the output resistance R0, then I can write V0 is approximately equal to AV into VI. So cross multiply is V0 equal to AV into VI, and you know VI and VS are approximately same, not exactly same. So I put approximately AV into VS, where AV is the voltage gain in open circuit. So when you open circuit the load and find out the voltage gain, that is going to be your AV. Okay, so from the name of the amplifier, you should first write what parameter we are finding. From the parameter, I can identify what will come at the input side, what will come at the output side, and accordingly, I'm going to write the explanation for the amplifier. That